In this video, I will record the answers to 3-1 lesson practice grade for those of you who are not going to be in class or want to review after class. So let's start right away. Question 1 is asking which of the following statements is true about this polynomial right here. So first of all, I need to notice that the I see here that the degree of this polynomial is determined by the greatest degree of the terms. So right here, I got 1, 2, 3, and 4 terms, and this one has degree 2, this one has degree 3. I'm paying attention to the exponents. The next one has degree 0. We uh, concluded that degree of a constant is 0, and here the degree is 5. So because of that, we know the greatest number is 5, so that's going to be the degree of the polynomial. So this is clearly not true, and also that term with the greatest degree, the term together, all the number and the sign, that is what is called the leading term. Leading term. And the number that is multiplying the variable there is called the leading coefficient. So we know that in that case, leading coefficient will be positive 2, right? So leading coefficient. So this is not going to be 1. And the polynomial in standard form, if we write it starting with the greatest degree, that'll be 2x plus 5. The next one will be 3, 6 plus 6x to the third power, and then plus x to the second minus 4. Notice the degree of the terms are in descending order. So that is the only thing that is going to be true about this. It is not a trinomial, because trinomial has only 3 terms, and this one has 1, 2, 3, 4 terms. So that's the only thing that is going to be true. So over here, we need to say that is correct, and we need to move on. So let's clean all these, and let's continue. Question 2 is asking to use the leading coefficient. Remember, is the term with the greatest degree is the leading term, and the number there, or the factor multiplying the variable, is what is called the leading coefficient. So in this case, we don't write it, but we know it's there. That is a 1 right here. So that is the leading coefficient. And that leading coefficient is positive. Well, first of all, it's odd, and it's also positive. So immediately I'm thinking this function right here behaves exactly the same as the one that is much easier, and we know f of x equals x. So because here the degree is odd also, and it is positive coefficient, so we know that it's going to behave like this. And that means that when I move to the right, so as x increases without limit, I can see the function goes up. So y increases without limit. And when I move to the left, or in other words, when x tends to negative infinity, what I can see is that the function goes down. So y tends to negative infinity. Remember, on the y-axis, positive infinity means up, negative infinity means down. And in the x-axis, positive infinity will be to the right, negative infinity to the left. So there are two things that are true right here. This is one right here, and there is the other one right here. So we'll have to choose those two and move on. So I will not do it here, but I will instead move on to the next question. I don't want the video to be too long. Question number 3 is writing this polynomial in a standard form, and then I need to find the degree and the leading coefficient. So I've been doing that first two questions, so hopefully that will not be a problem. But degree right here, remember, you pay attention to the exponents. So this is 8, that is 4, that is 6, this is 1, and this is 0. So I can put the term with the greatest degree first, so it'll be negative 1/4. Do not forget about that negative. M to the 8th, and then minus 5m to the 4th, and then, I messed up right there. This is supposed to be m to the 6th power. I didn't see that 6 right there. So, maybe I need to actually do it from the computer because that's going to be more clear for you. So I'm going to erase this here if I can. And I'm going to go back to this. And okay, so standard form of the polynomial. And I need to start with this negative 1/4 m to the 8th. Notice there is a fraction, so I'm going to do negative, and then I'm going to do the fraction. I'm going to put the 1 right there. I'm going to put the 4 right there. And I'm going to move to the right, m raised to, oops, I don't want to do capital, m to the 8th power. And then I need to move to the right. And then the next one, I said that wrong the last time, but it's going to be plus. So right here, plus m to the 6th power to the 6th power, move to the right, then minus 5 m to the 4th power to the right, and minus 6m, and last it's going to be 5. So double check that you have the same number of terms and that they are all combined, but they were before, so no reason to think they are not going to be now. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 terms. Now, they are also asking me what the degree of the polynomial is, and we know the greatest exponent is 8, so I'm going to type in here 8, and also the leading coefficient, and that's going to be a fraction. It's negative 1/4. So it says here type an integer or a fraction, so I'll do negative, and I will put 1 at the top and 4 at the bottom. So that's how you can answer that question there. So let's move on to the next one. Polynomial in standard form. I will let you guys do that one, but you can see that you will start with 6b to the 4th. Well, actually, it takes a little bit long for me to do it here. So, but I'm okay. B raised to the 4, and I didn't want to make this video too long, but hopefully you understand. So minus 2b, notice I'm not changing the signs, minus 2b raised to the 2nd power, and then move to the right, then plus 5b and plus 21. Again, you count 1, 2, 3, 4, 1, 2, 3, 4, so same number of terms. The degree is the greatest exponent, so that's going to be 4. And the leading coefficient is that factor multiplying the variable of in the first term. So that's going to be 6, and you can move on. So right here, again, I gotta pay attention only to the leading coefficient. So basically, you actually look at the uh, leading term first. So the leading term will be when the polynomial is in standard form, the first one. So you know this is odd, but this one is not positive because there is a -7. You know it's gonna be odd and negative. So you're still thinking of f of x equals now negative x, no x, but negative x. So the same line, but now with um, going down. So let's see, we can make a line right here. And you know that when you go to the right, the function goes down. And you know that when you go to the left, the function goes up. So negative infinity, let's say that when x tends to negative infinity, the function goes to positive infinity. And on the other hand, maybe I'm going to do that in green. When x goes to positive infinity, the function goes down. So that means that the y values go to negative infinity. So as x tends to infinity, meaning to the right, as x moves to the right, so I'm looking at this part right here in green, y tends to negative infinity. And that's the answer that you need to type in there. Um, I'm wondering if how easy it is to find that symbol right there, but I'm thinking that it is right here. So negative infinity, you don't have to pull out the calculator there. So let's hide it and let's move on to the next question. So this is an interesting question that it says the volume of water in a tank is modeled by this function. So I know that this here measures how much water and what x represents. So y represents how much water and x represents how many minutes after you uh, turned on the faucet, filling the water, filling the tank. So, what is the y-intercept? Well, I need you guys trained to see that the y-intercept happens, when you're thinking of any point on the y-axis, any point on this axis will have x coordinate 0. So you don't know about the y coordinate, but you know the x coordinate is 0. So the x value is 0. And when you plug in here 0, this becomes 0 because you're multiplying by 0. This becomes 0, and this is the only thing that is left over. So that's going to be the y-intercept. So the y-intercept is 2. And remember, this here means amount of water. So when I'm replacing x, which means minutes, that means that I replace x minute 0. So when is the minute 0? When I just turn on the faucet. And what is this here? The amount of water, because I'm reading the problem. So amount of water. So that means that the y-intercept is 2, and it represents how much water there was when I opened the faucet. Okay, so that's what you're gonna answer there. So I'm gonna clean this up and I'm gonna come here to do. So it is 2, and is the volume before right before you turn on the faucet, and that's it. Okay, so I'm gonna finish the recording now. So